Now we're going to look at solving a real-world application of polynomial equations. A new bakery offers decorated sheet cakes for children's birthday parties and other special occasions. The bakery wants the volume of the cake to be 351 cubic inches. The cake is in the shape of a rectangular solid, so something like this. Okay. They want the length of the cake to be 4 inches longer than the width. So if I call this length, so length equals width plus 4. I'll go ahead and call this width. And the height to be 1/3 of the width. So here's our height equals 1/3 of width. What should the dimensions of the cake be? Cake pan be. Okay, so let's do a little bit of math. Volume is length times width times height. So if we substitute to make it all in terms of W, it'd be, instead of length, I'm going to put W plus 4. I have the W for the width, and then I have the height is 1/3 W. So our volume in terms of just W is going to be, I got W times 1/3 W, so 1/3 W cubed. Then 4 times W times 1/3 W, so plus 4/3 W squared. And our volume, we know what it's going to be. It's 351 equals 1/3 W cubed plus 4/3 W squared. Now, if we were to subtract 351 from both sides, we would have 0 equals 1/3 W cubed plus 4/3 W squared minus 351. And then we want to clear the fraction. I think would be the easiest thing to do. So we multiply both sides by 3. 3 times that, 3 times that, and 3 times that. We're going to have, I'm going to do it up here, 0 equals W cubed plus 4W squared minus, and 3 times 351 is 1053. Okay. So now we have to, let's just think about this for a second. If we have the polynomial W cubed plus 4W squared minus 1053, that's one sign change. So by Descartes' rule of signs, there is one positive real 0. And we're going to go ahead and find it. I guess we can start by looking at the rational zeros theorem. And rational zeros theorem. Our leading coefficients of 1, so our P is going to be 1053, and our Q is going to be 1. So if we look at P over Q's, we're looking at plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 27. And at this point, we're getting kind of large. Plus or minus 39. I missed one, plus or minus 13. Plus or minus 81. Plus or minus 117. And plus or minus, oh, there's two more, 351 and obviously 351. So plus or minus 351 and 1053. The answer is probably going to be something on the smaller end. I'm almost thinking like 3 or 9. So let's go with 9, and if that's not it, we'll go down to 3. So 9, and we have 1, 4, 0, because there's no x term, and then negative 153, or 10,000, excuse me, negative 1053. Okay. So 1, 9 times 1 is 9, 4 plus 9 is 13. 9 times 13 is 117. 0 plus 117 is 117. 9 times 117, this is negative here, so it's positive 1053. So it's 0. So that tells us that 9 would be the width, because that is a 0 of this. So our width is going to be 9. The other thing is if we looked at the negative zeros, there's probably going to be 2, or there could be 2 complex. But negative distances don't really help us in the situation. So if W is 9, L is 9 plus 4, which is 13. And the height is 1/3 of 9, which is 3. And that kind of makes sense for a cake pan. Okay, and that's it for this subsection and this section. Okay, good luck with the homework.